Hi guys, good afternoon. So in the last session we saw about area types. Okay. Then we saw about LSA types. Correct. Now today let's start with the OSPF summarization. Now what do you understand with summarization? Creating a single route which will represent multiple networks of networks. So basically kind of we create a super net here. Okay. That rather than advertising multiple routes, we advertise a single summary route. Okay. So if we talk about the benefit of summarization, what do you think is the benefit? Number one is what? Yes. Reduce routing table. Your routing table sizes reduce. So that means that will consume less memory and less number of routes are getting advertised. So that means less CPU consumption also. So you will save less CPU and memory overhead, right? Same like in AGRP, also we discussed summarization, right? So same type of benefit is there that your link flag, okay, will not affect, will not affect the route. Bandwidth usage will be less. Okay. Now, if we talk about OSPF, like in EHRP, we did summarization anywhere we want. R1, R2, R3, anywhere you want, you can do the summarization. But in OSPF, it's not like that. In OSPF, if you want to do the summarization, summarization can be performed either on ABR or ASPR. Only on these routers you can perform the summarization. Okay. So let's say you want to perform on ABR. On ABR, so how you will summarize? You will go to router, OSPF process ID, then uh, area, area ID, then we'll say range, your summarized network and summarized mask. Summarized mask. Mask. Simply subnet mask. This is clear. And same thing if you want to do it on the ASBF, we have a separate command. You say router, OSPF, process ID, then you will say the address, your summarized network and mask. Okay. So let's jump into the lab. This is not right. This one I'll change it to 3P. This one we will use 23.0. So here R2 will become area, and here I will redistribute this network, so it will become ASBR. Okay. And let's say I'll advertise one more thing in the area 0. In this as 2.3. That all nodes. Let's take an access. Before that, let's write down the configuration for R1, R2, R3. So R1, gig 0/0, 12.1, 1.1, OSPF is there, 1.1 in the area 0. So 1.1 I'll not advertise here, okay? Instead of this, I'll say redistribute connected. Why? This will become ASBR. Okay. Then R2, Z 0/0 is 12.2. This is 23.2. And this is 2.2. So 2.2 is in 0, 12 is in 0. This is in. Okay, good. Then R3 is there, 3.3 and 23. Hmm? Interfaces, deal with the rest of the others. Here it's okay. Here also it's okay. So this will be now it's clear. Route ID not required. And this will be in area 1. This is also area 1. So this is the configuration of it. Okay. Everything is okay. Which one? Okay, submit. Yes. R1. R2, R3. So now copy, paste, copy, paste. This one also copy and paste. Here, now, now let them form the membership. So here we know now that right now what is happening. Your R2 is ABR, R1 is ASBR. So when we want to filter type 3, we'll filter on R2, and type 5 will filter on R1. But right now we're doing summary, so we'll do it on ABR as well as ASBR. Okay, and for summary, we need more number of networks. So this side, what I'll do is we have one, two. It's okay. Let me add more loopbacks on this side. This one I'll make it loopback on this one. R1, right? I'll make it loopback 0. And let's say I'll attach here 4 loopbacks. L1 will be 10, 1, 1, 1. L2 will be 10.2.2.2. It's early every day. It is at 3 to half an hour early, 40 minutes. So loopback 3, 10.3, loopback 4. Okay. So here, this is not the summary. Okay. This is, I'm just telling that, okay, if you want, you can use 10.0.0.0. And how many networks I can combine? Or what will be my CADR here? 0.0. Okay, let's clear it. No, I need to 0.3. Not 3. This will be 2 bits or 3 bits I need. 3 bits I need, right? So that will be 0 to 7, right? So what will be the subnet mask? Slash according to 29, like 248. So that means 0.7.255.255, right? And area. And if you are getting confused in this, what you can do is you can use same thing. 10.110.0.0.0.255. 4 times you can do. That is also fine. Right now here we just did what? We summarized all this. Okay, but this is not the summarization. I'm just, or else easier part is what you can do this thing only. Leave it. 0.255.255.255. That means any network starting with 10, advertise it. This is just for advertising, okay, not for summary. So there is a 5-4 redistribute space connected. Space will be there. Okay, so this is space here. Done. Now, so right now on R3, if I will check, right, we can see these are coming as a separate network. These are coming as a separate network. Now, what I want that they should be coming as a summarized network. So let's go on the ABR. And if you want to summarize it on the ABR, your command is area ID range, and then the summarized network and summarized mask. And you just need to make sure that this area here, right, the area ID that will be here, because on ABR, more than one area is there. So what will happen? That this area ID is what? Of the source area. Source area means from which area or to which area the particular summary the networks belong. Okay. Like if I see here, in my case, these all loopbacks, they belong to which area? Area 0. Okay. So on R2, when I'll say the command, I'll say area 0, then I'll say range, and then I'll give the range. Okay. Source area you're going to give here. So see here, I'll go on R2 because we can do the summarization on R2. I'll say area 0, range. Now, what is the summarized network? So let's say 10 dot, same 10.0.0.0, and CIDR, let's say 0.7.255.25. This is clear. Now, I'll say what? I think enough. Hit enter. It says cannot add this range. FF represents default. Wait on that. Because this is considering it as a default. That this is a default network and cannot be cannot add this link as okay. Subnet mask is there, right? I believe. 255.255.248.0. Okay, so here there will be subnet mask, not wildcard mask. This was our mistake. Hit enter. Now we can summarize. Okay. So once we have given it, now we will not see it. This is very slow. So earlier we were seeing these routes as a separate routes. Now we should see them as a summarized route. Here the OSPF process. Okay. Quick comment. Do show run type section OSPF. Okay, this will not come. Why this will not come? Understand why. Because right now I have redistributed it. I haven't advertised it. Okay, the networks are redistributed. So this is not area 0 network. Let me once say no, because I don't want to redistribute it, and let me give it as a route. Now take a look. See here, they were coming as an okay, no, that is fine. This is inter area route. That is fine. These are advertised in OSPF. Let's take a look right now. This is very slow. Still coming as 4 routes. So long. 5, 6, 7, um, 5 section was this is fine. On R2, how it is arriving? This is okay. So maybe these are coming from -5. Not coming from anticipated. Because this is internal. Hmm? Internal. Did you understand the problem here? 255, 248, exactly. Because I'm making a change in the subnet mask is incorrect. Okay. The subnet mask, we have to provide it correct. This will be 248 0. Okay. Now, if you will see, we will get a summarized network. Correct. Now we have summarized network. So that was our subnet mask, that was incorrect. Okay. All right. So this is, we can see. Same thing, but this time if we do it on the ASPR, okay, like instead of giving this network, if I say no, and this time on ABR also, I'll say done. So first of all, I'll redistribute. So we will see here that we will have OSPF external routes here. No, wait for it. You can see the 10 network has external routes. Correct. Now we will filter them and not filter them, summarize them. And this time summary will happen on the ASPR. So command is very simple. Summary address, same 10.0.0.0. Okay. And now when we'll see on the R2 and R3, we will see only summarized. Yes, this is your summary. Same here also, we'll see summary on. Yes. So you just have to keep take care of the subnet mask that has to be correct. Yeah. Okay. Next heading. OSPF filtering. Okay. So if you talk about OSPF filtering, we can filter OSPF type 3 and type 5 LSS. These are the LSS we can filter. Okay. Same thing. Type 3 is generated by ABR, so ABR will filter it. LSS are filtered on ABR, while the type 5 is ASP. Okay. Now, why filtering? What is the use? You don't want unwanted routes. Okay. Filter unwanted routes with the help of OSPF. Okay. So first, let's talk about type 3 LSA filtering. Filtering type 3 LSA. First of all, your type 3 LSA filtering, or you can say type 3 LSAs, can be filtered on AVR only. Okay. You can filter them in the outbound as well as inbound direction. That means you can block incoming LSA or outgoing LSA. Okay. These LSAs can be filtered in inbound as well as outbound direction. Okay. Thereafter, here which method? So only prefix list you can use here. Okay. You cannot use access list of route map. Okay. These things are not allowed. Here. So if you want to filter it, you will say, first of all, you will create prefix list. You will say IP prefix list. Then you will give the name. Action you will give that you want to permit or deny. So right now I want to deny. Then you will give network ID and CIDR. And to allow rest of the traffic, less than equals to 30. Then you'll go to OSPF. Then you'll see area, area ID, filter list, prefix. Then you'll give the prefix list name and you'll give whether you want to filter inbound or outbound. Okay. Yes, let's go to the lab. Very strong. Huh? Okay. So this is our lab. Type 3 LSA we want to filter. Okay. So here we have area 0. So that means who is the ABR right now? The R4 is the ABR. Okay. Start all the notes. First of all, why? Okay, update this configuration. You can delete remaining files. Okay. Wait. Okay. So now let's take an axis R1, R2, R3, and R4. Copy, paste, R2, R3, then R4. So R4 should form how many neighborships? Three. Okay. So let's wait for it. One. Okay. This is clear. Now, what we need to do, we need to filter type 3 LSA. So right now, if I check here on R3 to show IP OSPF database, so I can see that I am getting what type 3 LSAs. I am getting type 3 LSAs. So if I want to filter any sort of any one LSA, let's say I don't want the information about 1.1 to be going to R4, like this is R3. So I don't want that R4 should advertise this information, the ABR should advertise this information to R3. So I can filter this. Okay. Now, if I filter that route on the inbound interface, what will happen? It will not go in both of these areas. But I want that, okay, it should be filtered only in the area 3. Only in the area 3, nobody should have the 1.1 information. So I can filter it on the R4. So let's go to R4. Now, like I said that here, we have to give the area ID and we can filter it inbound and outbound, right? So if you are filtering inbound, that means incoming. Then this area ID will be your destination area ID. That means kind of what I'm saying, that if you're filtering here on the inbound direction, then whatever the destination area ID is there, that has to be there. Okay. And if you're filtering outbound, then you will give it source. Like this belongs to area 1. So area 1, then you will give the filter list. Clear? So right now, let's say I want to filter it outbound. I don't want that, okay, area 3 should get this. Right? So let's go here. And this is the R4 where I want to filter. So first of all, we'll create what? Prefix list. So I'll say IP prefix list. IP prefix list name I have to give. So let's say LSA T3. Type 3 LSA I want to filter. Right? Then after the name, what I have to give? Deny. I want to deny. Then I'll give a network. So let's say network I want to filter it was 1.1.1.0. Okay, and CIDR is /24. 24 or 32? 32 it is. Then /32. Okay. Then rest of them I want to allow. So I'll say permit /0 less than equals to 32. This is done. Router OSPF 1. Then area. Now, since I want to filter outbound, so the area ID will be source. That means from which area? So it is coming from area 1. So area 1, filter list, prefix, and what is the name? LSAT3. And I want to filter it in the outbound direction. Then, wait a minute. I think I have interchanged. Okay, we'll see this. Outbound direction, area 1. Wait a minute. So if I check on OSPF database, you see I don't see here 1.1. What about R2? Show IP OSPF database. See, in both the places I don't see, right? Because I filtered in the outbound direction. Okay. So in area 1 itself, I have filtered. I think I have said by mistake. And if I say here, instead of area 1, if I say area 3, then inbound to area 3, outbound to area 1. Okay, this is correct, not wrong. The statement is correct. See, first understand the statement. This area ID, okay. So if filtering in inbound direction, if filtering in inbound direction, Okay. The area ID will be the destination area. Okay. And if filtering in outbound direction, the area ID will be the source area. So right now we filtered in the outbound direction. So that's why we give the source. So that means we should filter all the outbound type 3 LSA from area 1. All the outbound type 3 LSA from area 1. Right? For this network, the type 3 LSA from area 1 will not go out. Simple. So if you understand here, today it's been like almost 20th time right now. So see here, this 1.1 should not go out of area 1. Simple statement. So it was not going out from area 1. It was not going in the area 3 also. It was not going in the area 2 also. That means if you want that, okay, a particular LSA should not be advertised in any other area, other than the source area, it should not be advertised anywhere else. We can use the outbound filtering. We can use the outbound filtering, because outbound filtering means what? That from this area, the LSA 1.1.1.1 should not go out. Simple. So it was not going out in the area 3 also, in the area 2 also. This thing is clear, right? And the same thing was happening. See here. Let's say if I say, where is the code? So if I filter it, take a look. If I say area 1, this is my area 1, filter the prefix list LSA type 3, filter the type 3 LSA in the outbound direction. So from area 1, the 1.1 information should not go out. So when I say this, you will see that on R2, I don't have 1.1 information. Wait for it. Let it update. This is R1. This is R5. Here we don't have. And also here we don't have. So that means on R2 and R3, the information is not going out. The information is not going in the area 2 and area 3. This thing is clear. Okay, we can verify. This is R2 belonging to area 2. No information about 1.1. And this is R3 in the area 3. No information about 1.1. This is clear. Outbound filtering. So in the outbound filtering, I said that, okay, from area 1, 1.1 should not go out. Simple. Now let's say I want to filter it in the area 3 only. So on the ABR, again, I'll say the same thing. 1.1.1.1 should not come inside area 3. 1.1.1.1 should not come inside area 3. So let's do one thing. I'll go and remove that filtering. So if I'll say no, I should see 1.1 information in both of these. Area 2 also. Wait for it. Right? I can see here. And also I can see here. Now I want that, okay, only in the area 3 information should not be there. So I'll say area 3, filter list, prefix, LSA type 3, and this time in the inbound. So when I say inbound means what? That in the area 3, the type 3 LSA should not come in. Right? Take a look. Wait for it. It will take some time. See, in the area 3, type 3 LSA is not there. What about area 2? Here we have. This is clear. Inbound as well as outbound filtering. See. Same way, instead of area 3, I want to filter in the area 2. So instead of this, I'll say no, and I'll say area 2. This time in the area 2 we should not see, and in the area 3 we will see. Wait for it. See, we don't see it here. And if we take a look here, we should see here. So we have it here. Clear? So this is the type 3 LSA filtering. Then next is about type 5 LSA filtering. Filtering LSA type 5. Okay. The first thing here, that again, this can be done only on the LSA type 5 can be filtered on ASBR only. Okay. And here the filtering is allowed only in outbound direction. Filtering is allowed in outbound direction only. Now you can filter these type by LSA with two ways. One is the distribute list command, and another one is the redistribute connector. Okay, so let's do it. There are two ways to filter. Number one, you can use the redistribute connected command. Okay, so in this method, we can only use router. That means your prefix list, access list, those things are not allowed. Number two is distribute list command. So distribute list command concept is same, we discussed in the AGRP, same way. Using distribute list command. Okay. So here everything is supported. Here we can use access list, prefix list, and route. All these are possible. Okay. So distribute list command I have already shown you when we were discussing about AGRP. Same concept. You will use a prefix list, you will use access list, and attach it with the distribute list. That's okay, and you'll give an inbound and outbound direction. Same concept, same comments, no difference. Okay. Only difference, instead of saying router AGRP, you will say router OSPF. Okay. So right now we'll go with the redistribute connected command. So note down the comments. Using redistribute connected command. Okay, type 5 filtering we haven't seen right yet. Practical we haven't done. First we'll do the practical. Okay, this is, I was like, I started new topic. Okay, now see here. If you want to go again, same concept is there. To select the particular route, we will create an access list. So create an access list here. You'll say access icon list, give the ACL number, then you will say permit or deny. Okay, so initially here we will give permit. Okay, so you'll say permit, your network ID, then wildcard mask. Once this is done, then we'll create route map to define the action, whether you want to allow or block. So you would say route map, map name. Okay, then you will give action that you want to deny, and you will give a sequence number. Then you will match the IP address, and here you will give your ACL number. Okay, then after you will say a route map, same command. Only you will say permit to permit rest of the traffic. This is clear. Then after this route map, we will attach it with the OSPF, all the redistribute connected to router OSPF process ID. Then you will say redistribute connected. Then you will say route map and your route map name. So that particular route will not be advertised by the ACL. So, note it. This should be greater. Okay. So you can say like sequence number if you want. That was explained in the EHRP as well. So greater than the nice thing. So now let's go and see it practically. Close everything. Even here we can see in the same lab. Okay. Let's access R1. And R4. Now let's access all of them. Now, since this is ASBR, so we cannot, it's not like we can filter in a specific area, we can do that. Okay. This will be filtered everywhere. That means you don't want to inject a particular route inside OSPF. So what I'll do is on R1, I'll see do show run type section OSPF. So I have 1.1 this network advertised. I'll say no. Done. Then what I'll say? First I'll say normal redistribute connected. Okay. And let me add one more loopback here just to show you. This is /24. Right? Will show 5. One is not there. 0. Okay. So okay. So I'll say input is loopback 1. 11 dot 11 dot 11 dot 11 255 255 255 255. Okay, why I'm creating another one? Because I want to show you that I'm filtering a particular one. Okay, so now I should see everywhere, like R4 and everywhere. Show IP route to OSPF. So you can see we have 1 and 11. Show IP route to OSPF. Here also 1 also 11 also I have. So everywhere we can see 11 network is also there. So this time I'm going to filter the 1 network. Okay, 1 network is here as well, and also here. Everywhere it is. So now on R1 itself, I'll filter it. Okay. So what I'm going to do on R1, I'm going to say access item list. Let's say 1. I'll say permit and 1.1.1.1 0.0.0.0. Right. Then I'll say route map, CCMP, dinner, then match IP address 1, permit 20. Then I'll go to router OSPF1. I'll say redistribute, connected, route map, and my route map name is CNP. And this is only in outbound direction, so no need to mention inbound outbound. Now in some time you will see that right now you are seeing 1, then we will not see the 1. Right? This is your type 5 LSA filtering. And also you can see here to show IP OSPF database. So you will not find it. So you can see. You won't find a type 5 LSA. That means ASB or summary LSA. Okay. For 1.1 we will not find. We will only have now. Is it clear? So you can see I do not have this particular route. Earlier I was having one route. Dot one route I was having. Here you can see. I don't have dot one route now. Earlier I was having, now I don't. Same way, earlier I was having two E2 routes. One was 1 and another one was 11. And now I have. This is your type 5 LSA filtering. Yes. Even for EIGR, redistribution, or EIGR, then the matrix, anything. Where? Now, as it is on connected network, you have given redistribute connected. Yes. And then the list. Not directly connected, then we have to that particular. We'll do it. Don't worry, we'll do it. We'll see it practical. Okay, it's not like I'm going to skip the redistribution part. But all the IGP redistribution, one single session, we'll discuss everything. The command here will say, instead of connected, you'll say redistribute EIGRP OSPF like this. So, see here. According to your protocol, you will give it. Okay. All right. So, any doubts? Yes or no? No. Then next thing is OSPF complete. BGP we have to start. Shall we start today? What do you say? Starting. LSA types. See, type 1 LSA. So any router that is present in an area will generate a type 1 LSA. Inside the, okay, let me go through the book. That will help you understand. I have shared a book, right? The CCI book. Confusing. Confusing. For easier language, you can refer this book. Very good. For easy understanding, you can refer this one. Now, if you talk about router LSA, first of all, every router will generate this LSA, and what it will list? Two things. One is the router ID, and second is that on that router, let's say if R1, R2, R3, R4 is there, so R1 will generate type 1 LSA. In the type 1 LSA, it will give its own router ID information and all the interface IP address that are present in that area. So let's say, for example, here, do show IP OSPF database, right? This is area 1, correct? In the area 1, we have two routers. One is R1, another one is R4. So R1 gave the information about 1.1.1.1 and R4 gave the information about 4.4.4.4, right? But if I advertise others also, let's say we have two loopbacks, right? Instead of redistributing, if I add them also in the area 1 only, like we use this command, right? If I say no, and also no redistribute connected, just to avoid confusion. And if I say network, let's say 1.1.1.1.0.0.0 area 1. This is done. And then we will say 11, 11, 11, 11. This is clear. Okay. Now if we check, we will show IP database. Okay. So here in this router link state, it is showing that, okay, there are two routers in this particular area who are generating what? Type 1 LS. Okay. So advertising router, this is the what? The router ID. This is the router ID. Then this link is directly connected. Okay. That is why it is showing you about 1.1 and 4.4 because this router's router ID is 4.4. Okay. And this guy has one link in this particular area, which is 1.1. This is clear. So this is the information they are having here, that they will list the router ID and they will list all interface IP addresses. Same thing you can go and check on R4. Now R4 is this is for area 0. You can see in the area 1, same thing. Okay. For area 2, if you will see, so R4 and this R2. So two information you will have. R4 information and 24.2 information. For area 3, R4 and R3 information. So take a look here. Is that clear? Okay. Then network LSA. Now network LSA is defining basically who is the DR. This is created by DR. And what it represents? It represents the subnet and the router interfaces connected to that subnet. So you will have information about the DR only now. According to type 2 LSA, you will have information about DR only. That okay, on a particular network segment, who is the DR? See here. So between R1 and R4, who has the larger IP address or larger router ID? R4. But now you know on R1 we configured 11 also. So still it is using process ID 1.1, I mean router ID 1.1 only. So if you see who is the DR here, understood? Who is the DR? in area 1. Same way, if you check in the area 2, so between 2 and 4, who will have a higher ID? Right? So if you say do show IP route, oh sorry, IP OSPF database. Show IP OSPF. Take a look, who is the DR between them? So here, who is the DR? R2, you can verify. Do show IP OSPF neighbor. Sorry, show IP OSPF neighbor. So you can see R4 is what? VDR. So your type 2 LSA shows you information about DR. Okay. Then type 3 LSA, this will be giving information about the ABR. This is created by the ABR and it represents what? The networks present in one area when being advertised into another area. So basically, this will show you networks that are going from one area to another area. So now see here, in type 3 LSA, you have 4 information. Okay. See here. 4.4, 11.11, 14.0, and 34.0. These are the networks advertised by the, right? Same way, here you can see. One dot one, 4.4, 11, okay. Then 192, 168, 14, 24. All of these networks which are advertised with the help of type 3 LSA by whom? You can see the advertising router only your ABR. Only R4, that is the ABR. He is advertising. And same thing here also you can verify. Same thing on R4 also you can verify who is the ABR. Yeah. Okay. Then next one is type 4 LSA, ASBR. So this is same like a type 3 only. But here what is the difference? That it will give you a route to reach ASBR. That means kind of you can say that, okay, it will help you to reach the ASBR. Okay. Now see here. So this is network summary. This is known as ASBR summary. So if we go here and if I redistribute these networks again, this guy will become ASBR. Okay. No. And if I say redistribute connected, now this guy became ASBR. So earlier you see that we were seeing only router LSA, link state, and summary, right? Now if I say to show IP OSPF database, so I have this is type 5. Okay, fine. Okay, I think I have that command for filtering. Show run section. Maybe distribute connected subnets. See here. See here. This is the type 4 LSA. Telling you about what? This is telling you about the ASBR, how to reach ASBR. So that link ID was 1.1. Okay. Type 5 LSA. This is going to be created by the ASBR for all the routes that you're injecting from different protocol to OSPF. That is the type 5 LSA. Type 6, not used. Type 7, this you will see only in the not so stubby area. That means when we configure stubby areas, that time we saw that whenever type 5 is blocked, router will generate type 7. These are the LSA types. Yeah. So then OSPF is done. Any doubts in OSPF you have? Practice it. You have doubts, you ask. Okay. All the required books I have uploaded, all the documents and everything is there. Right? Which one? This one. C. Type 4 LSA. This is like a type 3 LSA, but it will advertise a host route. Just one route to reach the ASPR. Okay. So if you take a look at the routing table, show the route to ASPR. Show IP route to ASPR. Okay. So you will see that we have one route to the, this is for output, sorry, and one host route here to reach the ASPR. Let's just reach this guy. This is your ASPR. Between those, it correct. Okay. Same thing here. You can see because that guy was using the outer ID 1.1. That's the process. It will show now. Okay, if we go here and we see to clear validity was clear process. Now it will use the router ID as 11. Okay, still it is using one only. Okay, so if it is using one, then you will see one only. Okay. Okay, then this is it for the day. Tomorrow we'll start BGP. Okay. So then today's task is what? You check about BGP. That's all. All right, guys, then see you tomorrow. Have a good day.